Hey everybody, for my chemistry project, I'm going to talk about oceanography. I bet all of you are thinking, Lacey, what is oceanography? We don't know what oceanography is. Don't panic, guys, it's pretty simple. Oceanography is a study of the ocean. See? Told you it was simple. Within oceanography, there are 4 different branches of study. These branches are biological, geological, physical, and chemical. Biological oceanography is the most critical branch of study. It records and studies the plants and animals of the ocean and their interactions and reactions within the marine environment. Another important branch within oceanography is geological oceanography. Geological oceanography focuses on the formation of the ocean floor and how it changes over time. Then you have physical and chemical oceanography. Physical oceanography is the study of relationships between the sea floor, the coastline, and the atmosphere. Chemical oceanography is the study of chemical composition of seawater and how it is affected by human activities, weather, and other factors. To put it as simply as possible for you guys, one studies life in the ocean, the formation of the ocean floor, the relationships between the sky, ocean, and land, and the chemical components in the ocean. Oceanographers measure things like the acidity in the ocean, how it affects marine life and the ways we can make it better, oil spills from sunken vessels and how it affects the ocean life, jellyfish stings and chemical components in the venom, the tidal waves and alternative energy in them. However, I'm only going to talk about one of these topics. Today, I'm going to be focusing on ocean acidification. I know, so fun. I will be talking about what ocean acidification is, why acidity matters, what causes a change in the acidity levels, how it affects the marine environment, and how we can keep a healthy pH, potential hydrogen, level. Let's start with the big question. What is ocean acidification? Ocean acidification refers to the reduction of the pH of the ocean over an extended time. The lower the pH levels get, the more acidic the ocean water gets. This is primarily caused by the uptake of carbon dioxide, also referred to as CO2, from the atmosphere. The steady rise of fossil fuels plays a huge role in the increase in CO2 and the decline of the ocean's pH levels, which is why you hear scientists and reporters talking about trying to lower the amount of pollution going into the air on a yearly basis. All of that contributes to the decline in the ocean's acidity, life, and environment. The carbon dioxide reacts with the water molecules to form carbonic acid, which can be bad for the marine animals if large amounts are created. This compound then breaks down into a hydrogen ion and bicarbonate. These hydrogen ions decrease the seawater's pH, so the lower the pH, the more acidic the ocean becomes, creating conditions that eat away at the minerals used by oysters, clams, lobsters, shrimp, coral reefs, and other marine life to build their shells and skeletons. Changes in ocean chemistry can also affect certain fish like clownfish from being able to detect predators. Wait, is that what happened to marlin?
Coral, get inside the house, Coral. No, Coral, don't. They'll be fine. Just get inside, you, right now.
I'm going to give us the happy ending we all deserved. Studies have shown that decreased pH levels affect the ability of some fish to locate a suitable habitat. When these organisms are put at risk, the entire food web is also put at risk. However, while some species are harmed by the decrease in ocean acidification, others benefit from it. Some oceanic plants, such as algae and seagrass, will benefit from higher CO2 conditions in the ocean, as sea plants require CO2 just like the land plants do. And we should all know by now the process of photosynthesis, right? Quick fun fact break. Have you ever wondered why the ocean is so salty? Salt primarily comes from the rocks on the land and openings in the seafloor. However, the rocks on land are a major source of salts dissolved in seawater. Rainwater that falls on the land is slightly acidic, so it erodes the rock. The minerals from the eroded rock runs down into the ocean, combining with other minerals, making the ocean salty. Anyways, as of right now, the seawater is an 8.1 on the pH scale. A 7 on the pH scale is neutral, while anything below a 7 is acidic. As we know, as the acidity levels decreases, marine organisms start having problems with their environment. So, with that being said, how can we keep our ocean at a healthy pH level? Well, one way we can do this is by reducing pollutants by buying non-toxic chemicals and disposing of all chemicals properly. Using fuel-efficient vehicles like riding a bike where you need to go is also a great way to reduce vehicle pollution. Reducing waste can also play a huge part in keeping our oceans clean and maintaining a healthy pH level. Cut down on what you throw away and shop wisely by using recyclable bags and choosing sustainable seafood. Lastly, treating the marine habitat with care by doing things such as fishing responsibly and practicing safe boating is super important to keeping not only the marine environment, but the ocean healthy and safe for both us and the marine life. Otherwise, you can kiss surfing and sandcastle building competitions with your family goodbye. Whew, that was a lot of information. Hopefully you guys were able to learn something new today. I know I learned a lot today. So make sure you guys take small steps to keeping the ocean healthy and safe for everybody. With that, I hope you all have a great rest of your day. Bye-bye.